So, as I said, you can't really hardly watch a Mars movie without having some dust storm show up, causing complications. I think the main point I want to get across, well, clearly we need to look at dust storms because they're an important component of the current situation on Mars. Movie tropes aside, we'll have to deal with dust storms. But also, the dust storms and the way they develop and the way they dissipate really do a good job of highlighting some basic analytical frameworks that we've talked about before, because there's both positive feedback mechanisms and negative feedback mechanisms involved in the origination and dissipation of these global dust storms. Okay. That's good. So, hopefully we're all familiar with dust devils here on the Earth. Anybody not seen a little vortex of dust blowing across the parking lot? Or okay. We used to be out in the Southwest where we'd see fairly substantial dust devils more frequently. Basic process going on with these dust devils is that you're going to have, for a variety of reasons, some local heating of the surface. So some part of the surface warms up. That's going to lead to an unstable situation with the atmosphere, because if the ground surface is heating up and the lower layers of the atmosphere are therefore heating up, and they are warmer than the upper layers of the atmosphere, which is going to be more dense, the upper atmosphere or the lower atmosphere? Lower atmosphere is hot. Upper, lower. Basic physics here. What happens to air as it heats up? It rises because it expands and it becomes less dense. And so if you've got less dense air down toward the surface and more dense air above, the air that's at the surface is going to tend to want to rise. And that if you've got the right conditions, those air masses will rise up through this kind of dust devil approach. You'll get this rising column of air. The Coriolis effect of the planet, whether it's Earth or Mars, is going to instill a rotation in that rising column of air, and that's eventually going to have enough oomph to pick up fine particles of dust, and that's what you can actually see when you see a dust devil going across. I've watched dust devils go across the prairie, if you want to call it prairie, or the desert in the Southwest, and you'll see this column of dust going across, and then it'll hit a major road where there's no dust to pick up. All of a sudden it looks like it disappears. Well, the air is still there, it's still moving around, it's still this rising column of air. But it's not until the dust devil moves off the road until it hits the dirt again, where it can start picking up dust particles, that you end up seeing it again. We have seen these dust devils on Mars both from the surface and from orbit. So here's a picture. This would be a picture by, in the lower left-hand corner, by the Spirit rover in the Columbia Hills region of Gusev Crater. And it's a little faint against the horizon, but you can see this profile of a dust devil that got captured as the Spirit was taking photos. Yeah, Jalen.
Why is it that these pictures are in black?
The rovers and the orbiters have different cameras for different purposes. This would have been a nav cam photo. The NavCam stands for navigation camera. The Spirit and Opportunity rovers have HazCam, which are these little tiny black and white cameras down on the chassis, which look for immediate hazards as the rovers are moving around. The NavCam, the navigation cameras, are also black and white. They're used to take stereo images so that the computer on board the rover, as well as the computers back at NASA, can build up a three-dimensional view of the terrain that the rovers are going through. For that, you just want black and white photos. Black and white photos are more efficient because they're not passing color information. The bit rate needed to get those images down is lower. So that's why this NavCam is in black and white. Now, realistically, most spacecraft will build up color images by having a black and white camera that they put different color filters in front of. So they'll use the black and white camera to take an image of object, terrain, or whatever, using I'll just do it very simplistically, a red filter, a green filter, a blue filter. You bring those data down, and then you can combine them and produce a true color image out of them. The panoramic cameras, which is, this would be a pan-cam image. This is probably, given the terrain, a pan-cam image from the Opportunity rover, because it's out in Meridiani Planum, which is a much more flat area. They are by definition color. Now, this is yet another side. You ask a question, I go rambling off. The Curiosity rover that just arrived within the last year or so on Mars. James Cameron was involved in the mission for a while with the idea of getting high definition stereo video cameras on the rover so that we could download high def 3D terrain models in real time. That ended up not happening. They had to de-scope the mission a bit, bring down the costs, so that would have been really cool, but we don't have that. Here's a picture of a dust devil from orbit. Given where the dust devil is, where the track is, and where the shadow is, how do you interpret this image? I mean, it's already kind of labeled for you.
It's a very big dust devil.
It's a very big dust devil. Dust devils on Mars can, extend up 4 kilometers.
Looks like it's like going in one linear path.
Yeah, it's going in one direction, but which direction is it going? Left to right or right to left? Yeah, it's going left to right. You can see the faint track on the left side of the screen. That is the area on the surface that's been disturbed as the dust devil has gone by. And then the shadow is projecting off to the right. So what do you know about the angle of the sun for this image? It's coming from the left. Okay, so again, building up the ability to interpret these images from orbit, it can be a little bit tricky, but yeah, the shadow is probably the most prominent feature in this image, and here's just another one. Here's a color image from orbit. Again, this is a huge dust devil in this case. I forget the specs because it's been a couple of years since this made the news, but I think this is a kilometer or 2 in height. And you can again see the shadow trailing off to the right there. So what do dust devils have to do with dust storms? Okay, positive feedback mechanisms are involved in the dust storms getting started, and then negative feedback mechanisms are involved in the dust storms eventually collapsing and the dust settling back down to the surface. So the positive feedback part first. We've already talked about how local heating is going to lead to the formation of dust devils. There's some pretty spectacular images that I think Spirit caught. Just, kind of automated photographs from the NavCam cameras. They capture 2, 3, 4 dust devils going across the Gusev crater area at the same time. Clearly those dust devils are going to put a lot of dust in the lower atmosphere. That's what they're doing. They're picking dust up off the surface. The dust in the air become little particles that the sunlight, incoming sunlight, can heat up. So you've got more dust in the air, and that dust is in turn getting heated up. You're going to get more heating of the lower atmosphere, which is going to lead to more dust devil activity, which is going to lead to more dust in the atmosphere, which is going to lead to more heating, more dust devil activity. That kind of positive feedback loop that we've seen before. And eventually you get so much building up that it becomes a kind of at least a regional storm. With all of this local heating, you're going to get a low pressure area with a lot of warm dusty air rising up into the atmosphere. That's going to lead to more surface winds coming into the area, which is going to continue to feed this process until you eventually get either this regional or global dust storm effect. Okay, so it's fairly straightforward, positive feedback mechanism. You don't have a dust storm, you get some local heating, you get dust devil activity, you get more local heating, you get more dust devil activity. Pretty soon, you've got a lot of dust up in the air. Okay, so how does this all come to an end? Well, by the time you get a lot of dust up in the air, what's going to happen to the amount of sunlight that's hitting the ground surface? Yeah, it's going to start shading the surface. When the surface starts getting shaded, the surface is going to cool off. You're going to basically shut down that dust devil, that rising air mass activity, and that's going to essentially kill off the mechanism that's leading to the dust being lofted up in the air. So what's going to happen to the dust that's in the air eventually? It'll eventually fall. Okay. Now it can take a long time for the atmosphere to clear. And remember when Mariner 9 arrived at Mars, our first orbiter in Mars? It arrived when there was a global dust storm. It took 3 months before Olympus Mons and some of the other volcanoes started showing up through the dust. So again, unless you're stupid when you're colonizing Mars, a dust storm is not necessarily going to be lethal, but it can be a real pain and make your life not very nice. This just shows some photos from orbit on the top photos for the approaching fronts from a regional dust storm. So it can be pretty impressive. You can see the difference between this chaotic terrain over here, which is showing up nice and sharp, versus this big mass of dusty atmosphere that's blowing in. And Hubble, of course, watching Mars long enough, has had the opportunity to see some pretty impressive global dust storms. So, back in September 2001, Mars was pretty much engulfed in a fairly global dust storm. Weather, not every regional dust storm that develops will go global, but it's pretty impressive when they do. Okay. So I'm going to throw out something. Global or regional dust storm season is the Mars Southern Hemisphere summer. Basically, that's if there's going to be a regional or global dust storm, it's going to happen when it's summer in the Southern Hemisphere. Now, we talked about seasonality between the Northern Hemisphere and the Southern Hemisphere. That was just last time. What do we know about the southern summer on Mars?
It's short.
It's short.
It's hotter.
It's hotter. Okay. So, to really kick off these processes, they're going to be most likely to happen when you're getting the most intense local heating. And that's going to be during the southern hemisphere summer on Mars. So, generally speaking, when LSB 250 to LSB 330, this part of the orbit, when the southern hemisphere is pointed toward the sun at the time when the orbit is close to the sun, that's when you're going to get the dust storms.
So, just as a question, when you say the southern summers are hotter than the northern summers, how hot are they? Because it's Mars, so it's cold.
It's Mars. It's relatively cold, but warmer than the northern summer. During the southern summer, I mean, if Mars had oxygen in a higher pressure atmosphere, during the southern summer, you could go out in a light jacket and you'd be fine. But obviously, the lack of oxygen and the low atmospheric pressure would kill you. But yeah, it's it's not going to be Death Valley hot ever on Mars, but it would be a reasonable spring day here.
Kind of like today.
Warmer even sometimes. Okay. So, this brings up an interesting problem. Both of the Mars exploration rovers, both Spirit and Opportunity, were basically directed to southern hemisphere sites. Spirit a little bit further south than Opportunity, and neither were necessarily expected to live through the first winter. When they did survive the first winter, they realized this could be an ongoing mission. So the rovers have, in the past, had two seasonal problems to have to deal with. In the winter, it's colder, and they're solar powered, and the sun is up in the northern hemisphere, so they have much lower power production, generally speaking, during the winter. And they either have to hunker down on a north-facing slope, or if they're in really good shape, they can do some limited science while they're working, trying to get through the winter. In the summer, they've obviously got warmer temperatures and more solar radiation, but that's also the time when you can get these dust storms triggered. And it was thought that both the rovers would eventually die when their solar panels got covered over with dust and couldn't generate electricity anymore. But the other nice thing that was found is that periodically the wind would come along, some of these dust devils, and would blow off the panels. And so every now and then the panels would get the dust blown off and power levels would spike up again. But Opportunity in 2007 was at the edge of a regional dust storm, not even a global dust storm like that one in 2001. And can't really see it really well through the projector. It'll show up better on the YouTube video probably. But as this regional dust storm developed, this image down here in the lower right-hand corner, Spirit and Opportunity have a camera whose sole function it is like every day to take a picture of the sun. So clearly it's a heavily shielded camera, but they take those pictures of the sun each day to get an idea of how much dust is in the atmosphere. Obviously, more dust, less sunlight coming in. Now, why is that critical for these rovers in particular to have that kind of data? Because they're solar powered, right? So, typically this camera would be taking pictures like this throughout the mission. But you can probably tell when this dust storm rolled into town. Basically, the tau levels, which is the measure of the opacity of the atmosphere, just skyrocketed. And very little sunlight getting in. So, opportunity had to basically be hibernated during this period. And there was concerns whether there would be enough power in the batteries to maintain the critical heaters to keep the equipment that is necessary for the rovers from crapping out entirely. Fortunately, it survived through the dust storm. The dust eventually, the dust storm abated, the dust settled, the opacity, the opaqueness of the atmosphere declined again, so more sunlight getting into the solar panels, and opportunity is still roving along as we speak.
So these dust storms last for like months.
They can, especially the global ones. Now, regional ones are not going to. Let's see, what do we have here for dates?
It says it starts like
Yeah, so
June.
probably in the third week of June or so that we're beginning to get the dust showing up. And, clearly I don't have the whole data for the. Well, actually, there is no more data after about the 20th of August. Why? Why is there no more data?
Because they put the
Because they put opportunity into hibernation, right? So they're not even going to take the power to shoot this one picture of the sun to see how opaque the dust is. They just shut it down and continue to monitor the storm from orbit, and then try to realize or figure out when they can bring opportunity back up.